Your objective for Lesson 25 is I will express whole number fractions using models and the number line. So we're going to work with whole number fractions, meaning fractions that are equal to whole numbers. And we're going to be looking at models and number lines whenever we do that today. Okay, so when we're looking at these two different models, we're going to write the fraction for what is shaded. Okay, so for this first model right here, we always know that when we're trying to figure out our denominator of our fraction, we always look at how many parts there are total. And whenever you're looking at this model, I see that there are 3 equal parts. And then when we're trying to find our numerator, we look at how many parts are shaded. And it looks like all 3 parts are shaded. So it looks like this whole model right here is completely shaded. So we would write the fraction 3/3 for what this is, this model. And we also know that anytime a fraction has the same numerator and the same denominator, that is always equal to 1 whole. And you can see even on the model, if the whole thing is shaded, then that we know is equal to 1 whole. So that first one's 3/3 and it's equal to 1. Now when we're looking at this next model, you see that I have 3 different rectangles in one here. So I'm really going to be thinking of the whole number 3. I know that whatever fraction I'm writing is going to be equal to 3 because I have 3 holes right here, and every single one of them are completely shaded. So the first thing that you need to be thinking about is what is the denominator going to be for the fraction that we have to write for this model right here. And the way you think of it is how many parts are in each one of these rectangles. And whenever you're looking right here, this rectangle has 1 part because this whole thing is shaded, so that's just 1 part. This rectangle also has 1 part, and this rectangle also has 1 part. So our denominator that we're going to be working with for this model right here is going to be 1 because each one of those rectangles only have 1 part. And when we're looking for the numerator, we're thinking how many parts are shaded in all. And there's 1 whole part shaded right here, another whole part shaded right here, and then another whole part shaded on this one. So that tells me all in all that there are 3 parts shaded in all, and that all of them have 1 part, and it is equal to 3 wholes. Something I want to tell you is anytime you have a number and then your denominator is 1, then it is always going to be equal to what the numerator is. So for example, if I had 6 as my numerator and 1 as the denominator, then it would be equal to 6. Because like I've told you before, you want to think of this fraction line like a division symbol. So if you asked yourself what is 3 divided by 1, it would be equal to 3. Same thing when we look over here. If you ask yourself what is 3 divided by 3, it would be equal to 1. So always think of that fraction line as a division line. So now we're going to go on. We're going to work on a few more of these so we can get ready for the problem set. Okay, so on your paper, I want you to write what fraction does this model right here show us. And if it's equal to a whole number, make sure you're putting the whole number that it is equal to as well. Whenever you have that written on your paper, you may push play to check your answer. Okay, so the fraction would be 4/4, and that would be equal to 1. The reason that the fraction is 4/4 is because there are 4 parts in the whole, and there are 4 parts that are shaded. And since that whole thing is shaded, we know that it's equal to 1 whole. Now we're moving over here to the next model where you see 4 different rectangles. So you have to be thinking about what whole number is that going to be if there's 4 different rectangles and all 4 of them are completely shaded. Be thinking about what your denominator is going to be based on how many parts each rectangle has, and then think about what your numerator is going to be based on how many parts there are shaded all together. So I'm going to see if you can get this fraction written on your paper as well, and if it's equal to a whole number, make sure you're putting the whole number down next to the fraction. Whenever you're ready to check your answer, you can push play. Okay, so the fraction would be 4/1, The reason that 1 is the denominator is because each one of those rectangles have one part, and the denominator is always how many parts there are in the whole. And then the numerator always stands for how many parts are shaded all together, and each rectangle is shaded completely, and there were 4 rectangles, so that's where we get 4 as the numerator. And we know that it's equal to 4 wholes because there are 4 rectangles and they're all completely shaded. Okay, we're going to do that same thing with these next few models. Okay, so over here for this first model, think of what the denominator is going to be, and don't let it trick you. Just because you see that there are 3 parts here and there are 3 parts here, the denominator is not going to be 6. Whenever we're writing the denominator, we don't add all the parts together. We just see how many parts each whole has. And in both of those rectangles that you see in that model, both rectangles have 3 parts, so that tells me that the denominator of the fraction that we're working with for this model is going to be 3. Now when we're working with the numerator, you do need to look at how many parts are shading, and you will add all of those parts together, and that's what your numerator will be. And you need to be thinking about if this fraction is going to be equal to a whole number based on what's shaded and how many parts there are. So I want to see if you can write down the fraction and the whole number for this first model right here on your paper, and then whenever you're ready to check your answer, you may push play. Okay, so what I was looking for was 6/3. The denominator is 3, like we talked about, because each one of the rectangles or the wholes have 3 equal parts, and the numerator is 6 because there are 3 shaded in the first one and there's 3 shaded in the second one, so that gives us 6 shaded all together. And since both of the wholes are shaded, then the whole number is 2. And once again, if you look at the fraction, you could divide 6 and 3, and that would be equal to 2 as well. Okay, now that we're going to move on to this middle one, this one's a little different because the last few that we've been working on, all the parts have been shaded. And this one, you can see that on this last rectangle, there's only one part that is shaded. So take that into account whenever you're trying to figure out the numerator, since the numerator is looking for the parts that are shaded. When you're trying to figure out the denominator, making sure you are looking at how many parts each whole has, and you need to ask yourself, is this fraction going to be equal to a whole number? So I want you to get the answer written on your paper for this middle model, and whenever you're ready to check your answer, you may push play. Okay, so the fraction for this middle model is 5/2. And you see that it's not equal to a whole number. The reason that this is not equal to a whole number is because not all of these are completely shaded. I'll show you what whole number it could have been equal to in just a second, but I'm going to explain why it's equal to 5/2 first. Okay, so the denominator for this one was 2, because if you're looking at each whole or each rectangle, you see that each rectangle has 2 parts, so that's where we get the denominator. The numerator is 5 because when you're counting all the parts that are shaded, there's 1, 2, 3, 4, 5 parts that are shaded. So the fraction for this would be 5/2. Now, a way that you could turn it into something called a mixed fraction, where it has a whole number and a fraction, is you look and see what could the whole number be. So when you look at these 2 rectangles right here, these are both completely shaded, so that tells me that I would have a whole number of 2 because these 2 are completely shaded. And then the only thing that you have left to do is you look at this last one and you say, what's the fraction for this rectangle? And the fraction for this rectangle is 1/2 because there are 2 parts and 1 part is shaded. So 5/2 is the same thing as 2 and 1/2. You just get your 2 from these right here, and you get your 1/2 from this right here. But you don't really have to know how to write a mixed fraction yet, but I was just going to show you how you did that in case you see it maybe on the map test or on some assessment that we have. So now you're going to go and you're going to write the fraction and whole number for this last model right here. And you're going to push play whenever you're ready to check your answer. So the fraction would be 3 over 1. The denominator is 1 because each one of these rectangles have one part. The numerator is 3 because there are 3 parts shaded in all. And the whole number is 3 because there are 3 holes that are completely shaded. And if you did 3 divided by 1, it would also be equal to 3. So now we're going to take a look at the number line. You're going to see whole numbers and fractions on the number line. 0 over 1 would be 0 because when you divide 0 and 1, that's equal to 0. 1 over 1 is 1 whole, and 2 over 1 is 2. 3 over 1 is 3. 4 over 1 would be 4. And then right now I've got the whole number 5, so on your paper, what fraction would go here that would also be equal to the whole number of 5? I want you to write that on your paper. So the fraction I was looking for was 5 over 1. And then for these last two blanks, what whole numbers would go there? So 6 over 1 would be equal to 6, and 7 over 1 would be equal to 7. So you can see the pattern. Any number that is a fraction and the denominator is a 1, the numerator is always going to be the whole number that you're looking for. Okay? Now we're going to look at this number line, and it says partition the wholes into halves. Well, when you're looking at the number line, you have to ask yourself how many holes are there on this number line. And I see the whole number 1, and I see the whole number 2, and I see right now that there is one part and one part, so this is one hole and this is another hole. So there's actually 2 holes on the number line, and we have to partition each hole into halves. So that means that we're going to have to take and we're going to put a line right down the middle of each one of these. So now this part has 2 parts, and this part over here has 2 parts. And then we have to name the fraction that it would be for 2 holes. So I want you to get this number line drawn on your paper so we can start writing the fractions on the different lines on this number line. So whenever you have this drawn, I want you to push play so we can move on. Okay, so when we are numbering a fraction number line and it has more than just 0 to 1, then I want you to envision that this part is not even here. Okay, let's think that this part wasn't even here. Like if we started at 1 and we went to 2, we would have to think of this part that would be on it. So we're just going to think that from here on, there's nothing on the number line. So if we're just looking at this part right here, you can see that there's 1 and 2 parts. So our fractions are going to have a denominator of 2. And this one right here would be 1/2, because if we start at 0, it would be 0/2. So this would be 1/2. I know that 1 would be the same thing as 2/2. And then I just keep going on, and I accidentally wrote 3 instead of 2. So 2/2. So this next tick mark would be 3/2, and then 2 would be the same thing as 4/2. So the fraction that names 2 wholes is actually 4/2. And once again, if you were to divide 4 and 2, you would see that 4 divided by 2 is equal to 2. So yes, we can see that that is equal to 2 wholes. You're going to have to do this on the problem set, or you're going to have to look at this on the problem set, and maybe on your exit ticket, so you do need to be familiar with how to do these number lines and make sure you're putting your fractions exactly where they need to be, and that you know what your denominator of your fraction is. So like I said, just imagine that this whole part of the number line wasn't even there. Okay, so now we are ready for the problem set, so if you want to get that out and have that ready so we can move on and do it. Number 1 says label the following models as a fraction inside the dotted box. The first one has been done for you. So this one, it said, what is this right here? And this is actually 1 whole. They could have also just put the number 1. And this one right here has been done for you. You saw this on the concept development. Actually, there were 3 altogether, and then there were 3 shaded, so it's 3/2. Which is also the same thing as 1 whole. So now we're going to move over here to this one, And whenever I look, I'm going to be thinking about first, what is the denominator? And I look and see how many parts are in each one of these rectangles, and each one of these rectangles has 2 parts, so our denominator is going to be 2, so make sure you're getting that on your paper. And then our numerator is going to be how many parts are shaded. So there's 1, 2, 3 parts shaded, so that tells me that my fraction is going to be 3 halves. When we come over here and look, once again, I'm going to be thinking about what the denominator is. So I see that this one has 1 part, this one has 1 part, and this one has 1 part. So my denominator is going to be 1 because each one has 1 part. And now I've got to figure out what my numerator is by seeing how many parts are shaded in all. And so there's 1, 2, 3 parts that are shaded. So my fraction is going to be 3 over 1, which is also the same thing as 3, the whole number 3. Okay, now we're going to move over here to the middle. They're going to get a little bit longer and a little bit more parts that are shaded. This one has 4 equal parts, so the denominator is 4. And then there are all 4 parts that are shaded, so the numerator is also 4. So the fraction for this model is 4/4, which is also the same thing as 1 whole. Moving on to this one, I see that this rectangle has 2 equal parts and this rectangle has 2 equal parts. So that tells me that the denominator is going to be 2. And whenever I count how many parts are shaded in all, if there's 2 shaded right here and 2 shaded right here, then that's 4 altogether. So the fraction for this model is 4 halves, which is also equal to 2. And then moving over here, we're getting to the ones that only have 1 part in all of the wholes, so the denominator is going to be 1. And then there are 4 parts shaded all together, so the fraction is going to be 4 over 1. And the whole number that that is equal to is just 4. So now we're going to move on to the bottom part of this front page, and I'm going to let you go ahead and do this part on your own. And whenever you're ready to check the answer for these 3 fractions, you can just play. Okay, so for this first model, the fraction was 6/6 because there are 6 equal parts and all parts are shaded. The second model, it was 6/3 because there were 3 parts in both wholes, and then altogether there were 6 different parts that were shaded. Over here, every rectangle or every hole just had 1 part, so that's where we got 1 as the denominator. And then there were 1, 2, 3, 4, 5, 6 different parts that were shaded, so that's where we get 6 over 1. So now we're going to move to the back where it's the number line. You've got to fill in all of the fractions that go with the whole numbers. So we're just going to rename the whole numbers as fractions. So remember, anytime you have 1 as the denominator, then the numerator is always going to be the whole number. So this first one is going to be 0 over 1. The next one would be 1 over 1. And then I want you to go ahead and fill in the rest of these fractions that would name these whole numbers on your paper. And you can push play whenever you're ready to check that. Okay, so 2 would be 2 over 1. 3 wholes would be 3 over 1. 4 wholes would be 4 over 1. 5 wholes would be 5 over 1. And 6 wholes would be 6 over 1. We're going to do the same thing down here. Some of them already have the fractions for you. Some of them have the whole numbers for you. So we're going to have to fill in some whole numbers and we're going to have to fill in some fractions. So if we have 10 over 1, then we know that that whole number would be 10. If we have 11 over 1, we know that that whole number would be 11. And if I have the whole number of 12, the fraction that we're going to be looking for is going to be 12 over 1. The whole number 13 would give us the fraction 13 over 1. And then I want you to go ahead and fill in these last 3 fractions on your paper, or fill in whole numbers and fractions on your paper, and whenever you're ready to check those, you may push play. I know that 14 over 1 would give me the whole number of 14. The whole number 15 would have a fraction of 15 over 1, and the whole number 16 would have a fraction of 16 over 1. So you can really see the pattern that those number lines take whenever we're working with whole numbers and renaming our whole numbers as fractions. The last one says, explain the difference between these two fractions with words and pictures. Okay, so I see the fraction 2 over 1, and I also see the fraction 2 halves. So the first thing that we're going to do is we're going to draw a picture. So for this first one, if the denominator is 1, then that tells me that a rectangle that I'm going to be drawing is just going to have one part. But the numerator tells me that there's going to be 2 parts that are shaded. So if this is one part and I shade that completely, then that's only one part shaded. So that tells me that I'm going to need to draw another rectangle that is exactly the same and shade that. So that would be 2 parts shaded, and both of them have 1 part total. So this fraction right here is really 2 over 1. So make sure you're writing that right next to the model. And then we need to show a model for 2 halves. So that denominator tells me that whatever whole I'm drawing is going to have 2 parts. So now I'm going to break this rectangle into 2 equal parts. And the numerator tells me that there are 2 parts that are shaded. So since this rectangle already has 2 parts, all I have to do is shade both of those parts. And now this rectangle is 2 halves. So it said you had to use words and pictures. So now we're going to have to use a sentence or maybe 2 sentences to tell why 2 over 1 and 2 halves are different. So we're going to need to write 2 over 1 is not the same as 2 halves. Because I'm going to have to go back between writing and drawing, because 2 over 1 is equal to 2 wholes, and then we know that 2 halves is not equal to 2 wholes, it's actually equal to 1 hose. So, and 2 halves is equal to 1 whole. So that tells us how they're not the same, because if they were the same, then they would both be equal to the same whole. So the answer is really that 2 over 1 is not the same as 2 halves, because 2 over 1 is equal to 2 wholes and 2 halves is equal to 1 whole. So that tells me why those 2 fractions are not the same fractions and they don't equal the same thing. Okay, so now you're going to be moving on to the exit ticket. Whenever you are finished with this, make sure you bring that to me so I can check over it.